Fitness Pro Mentors community, welcome to another episode of the podcast. I'm really excited. Listen, the Fitness Pro Mentors is all about helping trainers like you 2 to 3x their business. But today, we've got a brilliant educator, a good friend, and someone who just turned his back to me right off the beginning. If you're watching the live, what the heck? Joe DeAntonis. Joe, how are you, man?
I'm fantastic, Brandon. How you doing?
I'm doing good, man. I'm doing really good. So anyone who's checking this out, if you have not heard of Joe, you're completely insane. We did a previous episode with him about 6 months ago that you have to go back and check out. Fitnessstable.com, Move Integrated in Pittsburgh. Check them out. But we're not going to do an intro because, Joe, you're awesome. Let's jump right into it, man. Fascia.
Let's do it.
What the fascia?
So this is great. What's really interesting is, we're seeing a lot of things about fascia anymore, right? In the training world, it used to be like in the massage world, right? And then all of a sudden it just kind of melted over into the training industry. I don't know, maybe almost 15 years ago now, probably. And it's really picked up its pace there. And what's really funny is when you talk to people about what fascia is, most people don't even have the slightest inkling of an idea of how encompassing the fascial system is and what exactly the tissue is and all that kind of thing. So yeah, this will be a fun way into it to kind of learn more about it, what it is, why we worry about it, why should we do anything with it, or should we do anything with it?
Well, I think that's the thing, and I think that you're kind of nailing it, is I've heard it in two ways. Like, people either have no idea what fascia is and it's not even on the radar, or it's the panacea, and it is the one thing that fixes all things. It's the one ring to all anatomy, and it's like, oh, it's the secret. And so, let's just start like really, really broad. I mean, if you're thinking satellite view about fascia, Joe, do you think about fascia in your day-to-day when you're working with clients?
Oh yeah, it's an integral part of everything, because here's the thing. What you have to understand is the fascial system is throughout the entire body, right? So if we're working with muscles, if we're doing anything, we're trying to stress bone, we're trying to stress a muscle, we're trying to look at any other soft tissue, they're all fascia, right? Bone is part of the fascial system, right? So we used to teach it in one of the workshops, and I still kind of bring it up periodically, but you look at areas like, say, when you look at bone, right? If you take a bone and you put it in vinegar and let it sit for a couple of weeks, the acidity of the vinegar will eat away at all the minerals, right? All the calcium salts, all that kind of stuff. And all you'll have left is the fascial system portion of the bone, right? So you can make what they call them like science projects, or they call them rubber bones or whatever, right? So you take this chicken bone, throw it in vinegar, and in 3 weeks or whatever, you play around with it, and you can bend it, twist it, turn it. It still has the same exact shape that it had when the minerals were there. It just doesn't have the structural stability of those minerals making it rigid anymore, right? So like when you look at the trabeculae of the bone in like a X-ray kind of thing, where you can see the fibers running through it, that's the fascial system, right? The minerals fill in the gaps between that and make it rigid. But those lines where you see the lines of stress going through that's where the fascial system is running through there. That fiber is going through there, right? And with muscle, right? We talk about, if anybody studied any kind of muscle physiology, right? You have the 3 layers of fascia around each muscle, right? You have the endomysium, the perimysium, and the epimysium, right? And we study those 3 layers of fascia, and those layers of fascia continue beyond the contractile part of the muscle, right? And so, you have this contractile tissue that we call muscle fibers embedded inside of this whole fascial system thing. And so when we look at a muscle, it has a ton of fascia embedded throughout it, right? And like a lot of times the muscle fibers themselves don't necessarily attach to the bone, but the fascial covering that went over it will actually attach and embed itself into the bone. And again, when we look at different types of muscle ruptures, right? We have a musculotendinous junction tear, right? Which is basically where the muscle fibers, a huge portion of the muscle fibers kind of stop and the fascia continues on beyond that. You'll get a rupture there. But the other type of muscle tear is what we call an avulsion fracture. So an avulsion fracture is not where the tendon rips from the bone. The tendon actually pulls a chunk of bone with it. because the fascial system is so well embedded into the bone. It's part of the bone. So when it doesn't pull off of the bone, it pulls bone with it, right? So that's how well embedded that fascial system is into the bone. And how well embedded it is into the muscle, right? So all of these things, ligaments are also fascia, right? So
Yeah.
when we think of the fascial system, it's all the things that we're working with anyway. Um, so yeah, you have to have it on your mind when you're working with people.
So, I mean, anyone who's listening to this, you have to check out Joe DeAntonis' Cadaver Labs, which we're going to talk about at the very end because he's got a good series coming up. And I would say that when I came out for the first time, that was a reframing for me with you because I, like everyone, even through Tom Purvis, and I wouldn't say it's his fault, but I always thought of things like we have a ligament, and this ligament's attached to a bone, and there's a tendon that's attached to a muscle. And we've got fascia, and I thought of it like a sandwich, that it was all stacked together, but they were individual pieces. But it was the way that you exposed it and showed it with Cadaver Labs to really show that it was really a confluence of all things connecting and melting together. And there was just a different quality to the tissue, but it was really all one thing, but not one thing, which blew my frickin' mind. Because when you take that idea of like anatomy trains and they try to like connect specific muscles together, okay, we can connect some muscles together, but truth be told, that fascia literally connects stuff from that big toe on the left side to the finger on the right side. And it's just like, nuts. It's just nuts.
Yeah. And so Thomas Myers, his anatomy trains work is one of the things that got me thinking on those lines. And but I was reading his stuff, and it was really interesting because with anatomy trains, he picks out like, oh, there's these certain trains you have to be on the same track and all this kind of stuff. So a superficial muscle can only be on the same train as another superficial muscle, and then those become an anatomy train. But when you look at it from a mechanic standpoint, it doesn't matter if it's superficial, intermediate, deep layers. I mean, there might be one part of the body where there's 3 layers, another part where there's 7. So it doesn't matter how deep of a layer, how superficial of a layer your tissue's in. If it's tugging on the fascial system that the other one's connected to, it's going to have a mechanical effect on it, right? So it's not about like when anatomy trains did it. It was like, okay, this is connected to this and this is connected to that. And he even broke his own rules a lot of times. It was like things weren't connected, but he would say they were connected. It's like, oh, well, but he was trying to use mechanics. So when you really look at it with a mechanic's eye, then you can really see that when tension is put on one portion of the fascial system, it's gonna have a mechanical effect up a whole chain of tissue. And it can go a number of different ways, right? But you have to be able to, look at the fiber direction and see where that force could be transmitted. And this is the crazy part is, there's guys out there, like John Barnes and things like that, where they'll do, films of like living tissue, and they'll say, the fibers move and all that kind of stuff. And it's like, well, yeah, that's there's certain types of fascial tissue that's not really connected to things the same way as the structural fascial system, right? So the structural fascial system all has specific fiber directions, all based on force application, right? So when you look at something like the IT band, right? The IT band isn't an entity. Like when you go into anatomy, you don't dissect a leg and open up this the lateral aspect of the thigh and go, oh, here's the IT band. You don't see it. It's not there. There's not an IT band. The IT band is a theoretical portion of the fascia lata, right? And I say theoretical in the sense that it's there, it's physically there, but so the only reason it exists is because of the tension that's created by specific muscles tugging on the fascia lata, right? To create that vertical line of fibers, on the outer thigh there in that portion of the fascia lata, because the fascia lata wraps around most of the thigh, right?
Yeah.
And if you follow where the glute attaches into the fascia lata, you'll see diagonal fibers around your thigh in the direction of the glute fiber directions, right? Or the glute muscle fiber directions. And if you look where the tensor fasciolata attaches in, you'll see diagonal fibers where it goes. But where those two converge and they create a resultant vertically, right? Then that's where you see the vertical fibers show up for the IT band, what we call the IT band.
I love, I remember ever since you shared that with me, I've been trying to find a way to explain it to clients, because even today I had a guy come in, he's
Yeah.
like, my IT band's tight. And I had to get into that whole thing. And I think the easiest way to envision it is like if you have a sausage casing that's a plastic bag and you were to really pull hard on the ends of the plastic bag hard, that plastic bag, even though it's see-through, you'll get to the plastic end and it'll create that white line between your two fingers. And it's like, IT band, huzzah, you know? But
Exactly.
it's funny because we have that isolationist view of IT band fascia. And even through some of the muscle, you know, you and I took some very similar anatomy muscle courses, and there was even there, you know, a broad view, and we not need to work on all the muscles, but we start by looking at individual muscles. But it's so hard because they're so interconnected that how could you ever possibly say that this exercise is for vastus medialis? Because as soon as it contracts, because of local mechanical reasons and the wrapping of the fascia, it pulls on all of it, which makes it insane. But also leads into the interesting question of therapists and people who are really into fascial corrective work, fascial stretch work. It is the panacea. It is the one size that fits all. I mean, if your opinion, actually I shouldn't say that in your research. How the heck did people get there? And how does this blown up so much?
Well, I think part of it, there's a couple of big pieces of that. Number one, the way mechanics is taught in our industry is horrific, right? We don't learn real mechanics, right? So we take a kinesiology class and we take a biomechanics class, right? That kind of thing. And we don't really learn. I mean, if you showed some of the biomechanics textbooks to an engineer, they would be like, what is this? Because I've done it. And they're like, how did they come up with this weird stuff? You know, and because there's formulas in the engineering world that exist for all this stuff. But unfortunately, physiologists and people who were studying biomechanics who didn't really understand true mechanics, you know, like statics and dynamics, which are the engineering fields that you know, create this, you know, mechanics thing. And people that don't understand that, the terminology and the principles and all that kind of stuff, right? They look at the human body and they're like, well, it's different than that. And then they want to come up with a reason why it's different. And because they don't, because it's not like a pin-centered axis, right? So they think, well, it's not a pin-centered axis, so our joint doesn't work the way joint on a machine would work. And you're like, no, there's formulas, because in the real world, there's other axes that are more similar to like our joints and stuff like that. And engineers have figured out how to create a formula that will show you the mechanics of how that system works as well. And unfortunately, when you don't study statics and dynamics and more intensely into those fields, then they just start making stuff up, right? And so when they started bringing fascia into it, they don't understand joint mechanics very well. They don't understand muscle mechanics very well. And now they're trying to talk about fascia, because when you think you understand muscles and you think you understand joints, and everything that you do doesn't fix the person or help them get better, then you start searching for other things. And so I think that's where this fascial thing came in. They're like, oh, well, it must be the fascia thing then. And that's why this is tight. And we got to release that and loosen this. And the reality is, if you got each joint moving better by looking at each individual muscle and making sure that they're doing what they're supposed to do, most of it would probably get better, because when you're doing that, you're also addressing the fascial system. Yeah, it's
Yeah, I mean, that's what. So I think you may know this. I made a one-day course on post-activation potentiation, and it was a summation of what I learned from Macmillan that challenged my methodology around manual muscle testing. And one of the things that I talk about in there is how absolutely impossible it is to ever say that one of these pushes that we're doing for creating a contraction conditioning stimulus can work on one muscle, because that's insane.
Right.
But then you take that and you add fascia and skin and everything in between. The sensory somatic and the sensory response of every single one of those tissues are all happening concurrently. And I don't understand, how we got so far that someone goes, this is the fact, this is, when I do this, this is for fascia. I don't know how that happened. The skin's not involved, it's fine. The hairs don't notice anything. There's no changes in mechanics. You know, it's good, it's just fascia. And I just don't, I don't get that. So you've spent a lot of time exploring this. And I'm wondering, Were you just passionate about fascia, or was this kind of out of a need from conversations you were having with massage students?
Well, yeah. So I do a lot of workshops for massage students, right? So I have kind of a little bit of a connection with the Pittsburgh School of Massage Therapy, and so they do workshops every year, and just because of the nature of anatomy workshops, I get massage therapists to come and all that kind of stuff, and and there's a lot of things that come up about trigger points, and there's a lot of things that come up about fascial release and fascial stretching and all these different things. So, and they would come up with these theories that they've heard from other people. And this is, they took an entire class on it. And here's what they said, and here's why it's doing this. And I'm like, and most of it, and again, I'm not going to deny or denounce that any of these methodologies work or don't work, right? There's all kinds of modalities that we do that people see good results from. But the problem I have is in the description that they use of why it's working, right? And so a lot of times that's what I would say. They would say, well, because the fascia does this, that's why when we do this technique it works. And I'm like, well, I'm not going to say your technique doesn't work, but I'm definitely going to say that the reasoning they're using that you're saying it's working, it can't happen. You know what I mean? Like they would have these like really weird descriptions of what was supposed to be going on, which like be physiologically or mechanically impossible, right? Or implausible. And so I was like, it doesn't make. So then I started exploring a lot of these techniques and the descriptions about what they're saying they're doing and all that kind of thing. And so, I mean, basically what I've come down to is all these things are connected. Like you said, you're trying to work on one thing. You're trying to rub this one spot and stimulate the fascia or release the fascia or whatever it is. And it's like, how do you know which one you're doing? Like, are you releasing it and trying to get it to shut down? Are you stimulating, trying to get it to contract more? And we can't really judge which one. I mean, we can do EMG testing and see if it's something fires more or whatever, that kind of thing. But even then, we all know there's a million ways that you can screw that up too, measuring those things. So you're not really going to get a good read. So I figured, I just wanted to learn as much about it neutrally as I could, so that I could just explain. And I don't really promote a technique or a style or anything per se so much as I try to just express the information from as neutral standpoint as I can, saying, okay, this is from reading enough research on this. These seem to be the things that everybody agrees on, and it was like when I did my my research paper for my grad program, my master's degree. I did it on like active versus passive stretching, and it was really interesting because in all the passive stretching research articles, everyone agreed that when you passively stretch a muscle, it shuts down the nervous system messaging, right? And everybody agreed that when the joint stiffness was reduced at a joint, you had less stability there, right? Joint stiffness you get the biomechanical sense, right? Not like, oh, I got a stiff neck, right? We know what we're talking about, but for the people that don't understand, so joint stiffness is just a biomechanical term that means when there's the tissue around it, like the contractile tissue around the joint is stabilizing, contracting. When it's contracting more, it creates more joint stiffness, which creates more stability, right? So basically, everybody agreed that reduced joint stiffness led to joint instability. Everybody agreed that stretching muscles reduced neural messaging to the muscle that was passively stretched. Everybody agreed that when a muscle has reduction in neural activity, it reduces joint stiffness, right? But they never put all three of those together, right? So they didn't say, oh, if I stretch a muscle, it reduces the neural activity to it. That's going to reduce joint stiffness, which in turn is going to create joint instability, right? And so they would agree on everyone that did all this research agreed on all those pieces. They just never put them together. So when I put them together in my project for my master's degree, my professor was like, well, but I mean, the questions I my paper, I was just like, did you even read my paper? and it was because like the one article was like they only stretched one side, like they took sprinters and only stretched one hamstring and didn't stretch the other. And I was, I made this comment about, like why, how that would, number one, throw the gait off and all that kind of stuff too. And then the guy he just wrote on his comment was like, why didn't they stretch both sides? And I'm just like, why did they stretch either? What did you? It was like, did you read anything I wrote? And it was just so. But people don't. They put their blinders on and they believe the couple things that they learned. They don't want to open their mind to learning new information. And when you put pieces together like that, even when it seems to be laid out, they still like push back against it. So it's been a 20-year battle of trying to get people to 20 years.
Oh my god. There's a great quote that I heard that's been like on my mind, and it stands out so much, but it's that we will challenge all of our beliefs except for the ones we truly believe, those will hold closest. And I find that with academics and exercise land, right? Because they're all like, we're open-minded, we'll try anything. And then you get to one thing and they're like, no, that's squats are the best. But it's interesting because that whole stretch thing with the down regulation and force output, we've got this little bit in the potentiation course where I literally have a dynamometer and I have someone that goes into horizontal, end range, active, supine, horizontal, adduction, apply force, maximal voluntary isometric contraction. We get a number, say it's 20 lbf. We do it 60 seconds later, it goes up to 27, 28. And they say, okay, great, go stretch it. They go stretch it. They come back and do a maximal voluntary isometric contraction again, and it drops below the 20 to like 16 lbf. And then like, what happens? What do I do? And I said, just wait a second. They do a fourth one from doing the contraction, and then it goes back up to the 28. And they're like, what is going on? And it's really cool because, I mean, I've lost the sense of trying to explain what's actually happening. Like, I like potentiation as a broad blanket, but at the end of the day, you have all these things working together to make force production more optimal. And it's super cool. And on that note, which was coming back to you, and I want to get more into practical application of thinking of fascia. Despite all of your learnings, despite of all of the hands-on techniques that you've learned and been involved with, your primary mode as, like, I would say, a professional career trainer is exercise, which I think is sick. And you're a clear testament that you can make a full career using exercise with these thought processes and understanding the stuff around fascia. So, I mean, with all of your infinite wisdom and lack of mustache, Joe, why is it that exercise is your primary vehicle and you've abandoned many of the hands-on techniques that you've become aware of through massage and other techniques?
Well, and a lot of it's like you were talking about before. I mean, we know that, when you're poking, it's like, who was it? I think it was Chris Graney at one point. He was talking about like a Wendy's hamburger or whatever, and you got the bun and the tomato and the burger and the lettuce, and you push down here and you're hoping you're only going to squish the lettuce, right? It's like, no, you squish in the bun, everything in between, right? And so it's, when you're doing some of these techniques, I mean, not that you can't see benefit from it. And I still use some, I still use them periodically, but I'm always reinforcing with backup, isometrics, planned movement, like, the small increment range of motion to larger increment range of motion, that kind of stuff. And isometric holds and different things like that, because and very specific load application, right? You're applying a force in a very specific direction to try to affect a specific tissue or a specific portion of a tissue, right? You won't think about, I think us as people that have studied some of the things that we've done through, RTS versus whatever, we have a good understanding of when you apply force in a specific direction, you might be hitting, a portion of one muscle, not the whole muscle, or, that kind of thing. And if you change the angle slightly, you hit a different portion of it, right? And so, by doing those things, like applying exercise methodically in that manner, right now, and then by assessing where their range of motion is and what the comfort levels are in each position as they change and range of motion goes further, does it get less comfortable or does it stay about the same? Or so using a lot of output and feedback from the client, as well as thinking through what you're doing and why you're doing it, based on the way you're loading the force, the direction, the angle, all kinds of stuff, changing torques and changing, I mean, there's so many pieces to it. but it's, exercise becomes movement. It becomes the final goal for most people anyway, right? They want to get back to doing stuff. And, I can, I remember working on a couple of the Steelers, and they would come in for, muscle work or whatever, and they just lay on the table, and I'd be like, okay, I'm going to need you to push this way and push it. And they're like, I thought I was just got to lay here. And I'm like, no, this is an active session. Like, this isn't, I'm not your massage therapist. This is going to poke on a bunch of stuff and hope to release the right things and not release the wrong things and send you back on the field and hope for the best. Right. I'm specifically trying to get you to move a specific way better, more efficiently. And that's going to include you having to put some effort into it.
That reminds me,
And so,
I had a CFL guy that I got to work with one time. It was super cool, super excited, super jacked up. And he goes onto my table. I go to the bathroom. I come out. He's laying in his underwear, like completely everything off except for his underwear. And he's like, "Okay, so I'm ready." And I'm like, this is more of an active process. We're gonna be contracting. Do you mind throwing your? He goes, "Oh, you know what? I think I'd like you to see what's working." And I'm like, "Okay." And anyway, we did one session like that, and I'll never do it again. It was a bad scene.
yeah.
So
Yeah.
on this fascia note, I had a couple student questions, and Sophia Lee, she asked, what is fashion? Why should people care so much about it? I think we've talked about it. There's going to be more about that. Keith Shimon, who you probably know,
Yeah.
he said, why does this
Yeah.
picture look like he wants to fight me? No, seriously, what information, it's a sick picture. I love it. I wish I was like a fighter because I would do, but I can't. I'm not a poser. Seriously, what information sensors does fascia hold and transmit? So that's a broad question. But what information and sensors does fascia hold and transmit?
Yeah, so this is there's some really interesting information out there. So okay, so one of the things is people talk about the contractile component of fascia, right? And you'll hear people talk about that. And I've read all the research on that. I have it all. It's on my computer right over here. It's everything I could find on it. I mean, I've got Schleep, who's like supposedly the main guy that does all those things, right? And it's all really, how do you put it? It's not, there's nothing definitive in there. I mean, everything is kind of like, we're making a lot of inferences, and we're, and in all honesty, like, so let's say I'm dissecting a specimen and I know there's so say a muscle like pyramidalis, right? Small, pretty small muscle, superficial, very superficial. I've come across quite a few specimens that only have one side of pyramidalis, but they'll have fascial tissue almost every single time where the pyramidalis should have been. And so I wonder, in my brain, I'm going, okay, well, was that muscle just shut down? Did they rupture it? And maybe the nerve system got cut off to it and it just atrophied. And now there's just some fascial tissue there, right? Or did they never have one? Were they born without it? I don't know. And you'll never really know, but it's just weird things to think about. But then people say, okay, well, there's there's some contractile component to fascia. And they've never really proven it. There was some weird inferences in the Schleep materials and all that, but it was like none of it was definitive. It was pretty loose information. And I got to say, because if I looked at that fascial tissue of that pyramidalis that was atrophied, but the fascia is still there, if I looked at that under a microscope, maybe I would have seen some muscle type tissue in there, right? Because it used to be a muscle, right? And so things like that make me wonder, because the places where they found the contractile tissue was potentially because there wasn't a lot of description in those research articles. It wasn't descriptive enough where you could tell exactly where they were talking about and that kind of thing. So all I could do is make inferences based on the information they gave me. And it was kind of like, okay, well, maybe there was an atrophied muscle that they thought was just fascial tissue, and that's where they saw some contractile thing. I don't know. But even then, it was still kind of like, But now, another really interesting one, though, is there's a theory that the fascial system is like a fiber optic system, right? And this one's really interesting. So apparently certain tissues, like when you it's like, do you ever use a cup with the string in between, and you talk to your buddy and the neighbor next door, right? And but you have to put tension in the string, right? And when there's tension in it, when you talk, the vibration will go down the string, and then they can kind of hear you. It's hear you as kind of a, but I mean, sometimes if you do it right, and you get the left tension in there and the right kind of cups and everything, you can kind of hear each other, right? But you get the idea. Like if you have tension in that string and I send a vibration down it, then you may get the communication there, right? And so what they're saying is if there's proper tension in the fascial system, and say I roll my ankle, they've done some stuff where they put sensors in the brain. They measured. I don't know if they did it with EEG. I can't remember. I'm trying to think now how they did it. It's been a while since I looked at this one, but they put sensors in the brain, and they could tell when the neural message came through. But before the neural message came through, there was another message that came through, and they were insinuating that that was the fascial system sending a message through this chain of tissue. But the problem is what they started finding with that is like, if it, like, so I roll my ankle, and if I have something unstable in my knee or my hip and the fascia isn't tight through that area, that message is going to get distorted or not going to get sent the right way, right? So everything, it seemed like, according to what they were saying, everything had to be working optimally for this system to be functioning optimally, right? And so like if I put tension through that, and that message is going to send up through back to my brain so that something can get back down there to readjust my ankle so it's in the right place or whatever, that the whole system would have to be working optimally for that to happen. But it's kind of a neat theory. It's interesting. There was some kind of cool pieces to that. Yeah, it was pretty wild. And but it seemed like it was more like they called it fiber optics, and I mean, there's a couple people that talk about it, and they were like, well, it's like it moves like at the speed of light, and I'm like, well, I don't know that we'd even be able to measure that in the body. Like if something that went from my ankle to my brain that fast, I don't, if it's going the speed of light, I don't know if we have anything that could even measure that fast. You know what I mean? Like, and so, but now like a vibration, maybe like through the string, right? Yeah. I could see something like that. That makes more sense. And that would make more sense with tension, like we're talking about from mechanical sense, the mechanical tension that's put through that tissue that's transmitted up an entire chain. Right, that would make sense to me more so than like a light being shined through, instead of light. But I think the reason they came up with the fiber optics, I think it was a John Barnes thing again, where he took I'm sorry, John Barnes was talking about it, but there was a neurosurgeon that what was his name? It was an Italian guy, I think. Start with a G. But yeah, hey, forget about it. That's it. But I think his name started with the G. It was like like Gambetti or something, whatever. But he was a neurosurgeon, I think, and he took his scope and shined it like under the fascia during a surgery, like during for a living specimen, right? And he videotaped it through the scope. And it was kind of cool looking, and it was kind of neat. And then, of course, everybody like ran with it, like, "Oh, this means this," and you're like, "I don't know that it means anything other than he shined a light on the fascia," and but anyway, it was
The body's messed up, man. I mean, it's funny listening to you talk about it. You hear everyone talk about everything being the best thing and then also being the worst thing at the same time. And the number of things that could go wrong that could influence your body and change locomotion, like you have a scab and it creates an inhibitory response and everything goes weak in that area from the skin. Your fascia gets pinched in your ankle because there's not enough tension going through it, down, you're going down. You got material damage in your meniscus, going down. Ligament tear, and it's just like a series of ridiculous, super important systems that all have to work concurrently together. And I would say that what I love about your perspective with the fascia stuff is, I've heard it like a panacea, and it's not.
Yeah.
But it's also really important to understand, because I don't know, and I would love to hear what you think about this. In my opinion, understanding fascia doesn't change my day-to-day thought process with the client in a big way, but it helps me to recognize that when I do something in this plane on this ankle, it could affect a lot more stuff, both from the muscle connection end, the nerve end, the fascial end, the sensory skin end. It's all together, and we have to just recognize that it's there. but it's not the thing. It's just a thing, I don't know. What do you think?
Yeah, no, I totally agree. It's it's I don't know that anybody should change their mode of operations based on learning more about fascia. But like you said, what it does is in the back of your mind, you're going, okay, where it's going. Well, like even like when I started doing the muscle activation stuff, right, and we're poking on specific muscle attachment points and all that kind of stuff. Some weird things happen to some people, whatever. And I remember one of the things I did was I got the reflexology charts out and was looking at the bottom of the feet and that, and looking at like, okay, I was like basically overlaid a map of the foot and where all the muscle attachments of the foot are with the reflexology chart, right? To see, like, okay, is this muscle potentially connected to this organ, or that kind of stuff. And so just keeping your mind open to things like that, because I know people that go to reflexology regularly and swear by it, and it helps them with their digestion or whatever they're working on, right? And it's all kind of cool. Is it placebo? Is it real? It doesn't really matter if it's helping them, right? And it was the whole thing. Like any modality that you're using, as long as you're not hurting people and they're seeing a potential benefit from it, I think we're doing okay. And as long as we're being respectful to the body and we're respectful to the systems of the body, I think I got to get a charger here. I think my battery is going to die. Hey, John.
No problem. You grab your charger. Is John there?
He's here. Yeah. Hey, can you get a charger for me?
If anyone's listening to this on the podcast, we're doing this live with Joe DeAntonis. So he's at Move Integrate. He's got his partner, John, there, and he was at Wizard. We're going to have him on because he's an entrepreneurial marketing machine. So that is what we're dealing with right now. Is he right there?
He's right here. Yeah. Here, come
John.
say hi.
John, come say hi on the podcast.
Yo.
Oh, hey there, John. How's it going?
Ooh, I lost audio.
All right. How are you? I can do it.
Excellent.
Yeah.
John, we talked. We got to have you on the podcast there, sir. I want to talk to you about your marketing entrepreneurial brain. You're a wizard. I love you.
Thank you. Yeah, let's do it. We'll throw it down. I changed my number and I didn't get to let you know about that, but I'll have Joe give it to you.
No problem. When we're off, you send me your number. That'll be great.
All right, sir. I'm gonna get a charger from. Hold on.
Thank you, John. So everyone, if you're listening to this right now, as you can tell, Joe's got a large amount of wisdom all around the fascia, and I think that you should definitely spend some time learning a little bit more about it, because the more you can learn about each individual piece within the system, skeletal muscle, ligaments, the tendons, the fascia, whatever it is, it can all concurrently help with your thought process. Joe also, and I'll bring this up in a second, he spent a lot of time studying mechanics, engineering background, and studied with Tom Purvis through the RTS program. And all of that creates a really unique thought process stacked on top of this fascia info. Anyway, I got Joe back now. Can you hear me, sir?
Yes, I'm back. Kind of.
We're figuring out charting.
Here, we're going to do this.
That's awesome.
Yeah, that's it. Oh, here, just bring it down here. Move this over here. There we go.
Move, integrated physical culture. Perfect marketing shot right there.
Yeah, look at that. Perfect, huh? How about that?
Absolutely perfect.
Worked out
Cool.
amazing. What's this going on here with this thing? Oh, there we go. Okay. All right. Oops.
Joe, I want to ask you, there's actually a great question from Lucy Dabrowski, who you know very well.
Yeah, Lucy.
And actually, Lucy, shout out, she's actually working here now, which I'm super excited about. She's a frickin' wizard.
Yes.
But she asked a great question, and I think it's a cool one because we've been talking about fascia at kind of like a different level, kind of like breaking things down, the mechanics a bit. She asked, how do you explain fascia to clients? And how do you explain fascial stretching to clients? So like if you're speaking client language, how would you go about doing this?
Yeah, so we try to do a lot of teaching to our clients, right? So we do explain a lot of this stuff to them, but the fascial stuff, I don't necessarily explain fascia as much as I talk more in sense of muscles because people are more familiar with that, right? And because the fascial system is so integrated with the muscular system, right? Well, when I talk about what we're working on and what we're trying to do, it's typically muscle related because they relate better to that. And so even if I know, in my head, there's this kind of fascial connection between these muscles, I'll talk about, like how this muscle connects to that muscle mechanically, and we're trying to train this tissue chain, and it's basically like a muscle chain more so than it's like a fascial thing, right? Even though the fascial system is highly integrated with that, I don't because most of them don't. And now if it's like somebody who's really interested in it or really just kind of want to nerd out with me on it, which I have a few clients like that, some physicians that like just kind of get into it and they're like, man, I didn't even know. You're like they don't even know. Like I have surgeons and I mean, one of my, what is kind of funny. Like two of my famous clients I had Peter Janetta, who was a world-renowned neurosurgeon that had a stroke. He was coming to me for quite some time, and I was helping him kind of try to just get some movement and some function back after a stroke. And because what I've seen with stroke patients a lot of times is the stroke shuts down a certain area, and of course there's the muscles that are cut off based on the part of the brain that was affected by the stroke, right? They're never going to get function back in those muscles. But what ends up happening is there's excessive torque at the joints where those muscles control motion at, right? So what ends up happening is that other muscles at those joints start to shut down because they're just taking too much load over time. So when we start working on movement at those joints and the stimulation starts to come back to the muscles still have function and they start moving better, so like guys like him, who's a neurosurgeon, right? He loved it. Like we would nerd out on it, and all this kind of stuff. And then Freddie Fu, who was the orthopedic surgeon for the Steelers, he was a client of mine as well, and he would just go. He would be like, "I'd rather go to you than Pete." He oversaw all the physical therapy at UPMC, at University of Pittsburgh Sports Medicine, and he would come to me when he jacked something up, and it was great. I'm like, really? Like, so, but that's the kind of thing. It's just funny. But again, so we would nerd out about that kind of stuff. And I have a couple other clients that they just want to do it. And I've had quite a few clients come to my anatomy workshop because they just want to learn more about how their body functions. But for the most part, I mostly just talk about muscles to my clients.
Okay, I got a super random question for you. And it's something that I've thought about quite a bit. It's not fascia related, but it sort of is. It's actually more of an ethics question. And I want to just get your thoughts on it because you said something twice that got me thinking. There is hundreds of thousands of people in a pseudo holistic world that between personal training and physical therapy that say that they're doing something like I don't want to name anything, but they have a name for it. It's a unique certification, whatever they want to call it. You call it road microphone therapy, sure, right? And they say that they do this thing that touches this part and makes this part relax or makes this part stimulate. And the thing they do, the road microphone physical therapy, it makes people feel better. People leave and they feel genuinely better. But the mode and the way that they're describing it and the thing that they're doing, there's no science that actually truly backs it up. It's the most pseudoscience explanation. And is it inhibiting or whatever it is? So I want to ask your thoughts. Do you think it is ethical or unethical if someone truly doesn't understand or at least has a thought process of what's going on when they're applying force into someone, but that force application is having a positive response, even if they're saying some crazy snake oil description, but statistically has a positive response versus a negative response? I don't know if that makes sense, but I'm just thinking.
Yeah, so it's a great thought, and the problem is everybody, because you're going to see research out there, and the researchers that did it believe wholeheartedly that their research isn't fatally flawed, that their research is accurate to the best of their abilities. And it might be, but I'm not saying that their abilities are bad. I'm just saying they're probably missing out on some things. And, because I've reviewed a lot of research, and, most of the research in the exercise industry specifically, because that's mostly what I've researched, is much of it is fatally flawed, predominantly because nobody has explored the mechanics extensively enough. And so other researchers will agree that their research is valid because of what they know, it's as accurate as they can be, right? Which is, so it's good. And so when they're using those descriptions, they're being as accurate as they know how to be. So it's hard to hold them liable for, like it'd be like, oh, is it unethical? But I mean, I think the reality is we have to make it known that without understanding mechanics, the research that we have done or are doing in the excess physiology world, kinesiology and biomechanics and all that it's pretty shoddy research. And so at best, and so I think we really need to understand that and start teaching people mechanics on a higher level.
Yeah, I
I
think
hope
you're right.
that does it.
Yeah.
Yeah. And again, like I said, I can't hold anybody liable because most people are doing what they do. They're doing what they know. Their their intentions are good.
Yeah.
And so and a lot of them are seeing good results with people.
There was a great
So
pardon me. There's a great Macmillan thing that he explained to me once. Oh, your headphones might have kicked off there.
Yeah, I think so. Yeah.
The great thing that Macmillan talked to me about one time that I thought was interesting, and he talked about a study that he was involved with, and that study was flawed with its actual testing procedure around exercise, and that blew the rest of the study up because the position they were putting the testing participants in was messed up enough that it wasn't consistent between A, B, C, and D, and it threw off the whole thing. And if he sees that in one controlled scenario, I couldn't imagine how often that happens in other scenarios.
Oh, it's you can't even imagine. Like, I don't know that I've ever read, especially in the physiology world, or in biomechanics, any research that I haven't found significant flaws in. Right, and again, not to say you can't get good information from that research. I mean, you still can, but but some of the inferences they make in their they're just you can't make those statements. You know what I mean? But there are pieces you can get from it. And that's the thing is, but you have to know how to read it, or you're going to read into it the way everybody else does, or the way the researchers understood it, and they're going to go, oh yeah, this is good because X, Y, and Z. But it goes back to that. I mean, I remember Macmillan. Charlie did that. He gave the. He made a copy of a research project they did. It was like in the mid '90s or something like that, and it was talking about like all the PNF stretching styles. Active, contract. Passive. The whole thing, and. And it was funny because, like, in the end, the people doing the research were like, "Oh, it was the effect was paradoxical," and you're like, "No, you just had a thing in your head that you thought was going to happen, and it didn't happen that way. So it seems paradoxical to you, but if you would have just stepped back and looked at the information that you did, you'd realize, oh no, that makes perfect sense. You know what I mean? And it was the whole, it was the active contraction." Heightened, so it was like basically they were testing, tension in the hamstring, like the amount of EMG activity in the hamstrings. And when they did the passive stretch and they measured the EMG contractile amount of the hamstrings, and then they did active contraction of the hip flexors and knee extensors. I think it was knee extensors actually, and their leg got further. So they got more range of motion. And but the tension in the hamstrings was like the contraction of the hamstrings was greater, and they were like, oh, that's weird. It should be, if you're going to get more range of motion, hip flexion and knee extension, the tension in the hamstring should be it should be relaxed to allow you to get there, as opposed to like contracting harder. And I was like, no, that's awesome, because that means your hip's more stable and your knee's more stable, and it's great. It is just fun.
That is awesome.
That is awesome. Cool,
This
Joe.
has
So
been
this has
super
been
helpful.
super
Want to
helpful.
ask you,
Want to ask you,
what's the final word
what's
on
the
fascia?
final word on fascia?
So learn about it. Understand what in the body's fascia, right? Like we talked about, the bone structure, the muscle structure is embedded in fascia. It's like different ingredients in different parts, right? You've got like minerals embedded in the fascia to make it more rigid. You've got contractile tissue embedded within the fascia to make it be able to contract and release. You've got fascia connecting from one tissue to another to create stability and to, but again, so even if the fascia would have a contractile component to it, it's not going to be enough to really stabilize and move a joint the way a muscle contraction can, right? Because those guys are the ones that are meant to do that, right? So the reality is if you're using a fascial release technique or some kind of fascial technique to try to make big changes to someone, I think you're barking up the wrong tree. I think you need to understand the muscular system better, get the muscles functioning better, and releasing better, right? And I think that's the big thing is like when you say, like, I have a tight IT band. Is it really a tight IT band, or is it the muscles that attach into the fascia lata that are engaging and creating tension in that tissue? And you need to figure out why they're engaging hypertonically, right? And so, I think understanding the muscular system, but understanding how the fascial system is related to that and related to all the other systems is imperative for us to really understand human function. And I think the bottom line is, I just got contacted by a group that are doing gait analysis, and one of the things they told me, they were like, well, we're looking to simplify our gait analysis process so we can tell it to clients. And I'm like, our problem with our whole industry of exercise and rehab and everything is everybody's looking for a simple process to try to describe the most complex machine on the planet, right? And you got to understand that we live in one of the most complex machines on the planet. I mean, we live in it, and we need to pay attention to it. We need to understand it, and we need to work with it, negotiate with it, and get it to function the way it's supposed to, and not simplify and dumb things down, because that's where we get in trouble, because we try to make a cookie cutter plan and you can't, so I think we just have to understand it's complex. It's going to be complex. Get over it.
And so I want to throw this out there, Joe, as like a last thing, and I love your thought process. Joe has an incredible amount of knowledge, as you can all tell. I mean, he's really just touching the top end of his knowledge. And you have a series of cadaver courses coming up that really takes everything you've learned from mechanics land and everything you've learned from anatomy land and makes it the most pragmatic experience possible for trainers. Do you mind telling everybody a little bit about that?
Yeah, so it's typically, we do like a Friday evening, we do like an intro lecture, which is, people always want to miss out on that one, which is the most important part, because it's like the foundation portion to going into the lab. So we do this intro lecture that talks about what we're going to see in the lab and how to like kind of get a description before we go in. Saturday, we spend the whole day, that would be like a Friday evening. Saturday, we spend the whole day in the lab. And then Sunday, we spend anywhere, usually about a half a day in the gym, exploring stuff that we looked at in the lab, loading the body, kind of looking at tissue chains, looking at how to load certain things to put stress on one area and more stress on one area, less stress on another area, things like that. So we do that lecture portion that's really informative and kind of gets you in the mindset to be in the lab. We spend a full day in the lab looking at muscle attachments, fascia, fascial lines of the fiber alignment in the fascia, the fiber alignment in the muscles, and then we spend half a day in the gym, like exploring and loading and really kind of putting things into application, so that it wasn't just a goofy course you went to and saw a bunch of cool stuff and then go home and don't know what to do.
Well, Brad Thorpe says this course is awesome.
It's awesome.
Love Brad.
Well, Joe, thank you so much for your time. It was absolutely a pleasure having you on. I love you. I mean, I respect you professionally. I find you a good friend, and I'm just super glad to have you in this little world and all of your knowledge. Thank you.
Thank you.
Yeah, thanks, Brandon, for having me again. Appreciate it. And it's always a pleasure talking to you. And well, next time I'm in Toronto, we're gonna go get beers or something.
T-shirt swap. T-shirt swap.
T-shirt swap.
There we go.
All right, Joe. Thank you so
All right,
much.
brother.
We'll talk to you
Joe,
soon,
thank
man.
you so much.
Great
Talk to you
talking,
soon, man.
Take care. Peace.